Hi everyone, welcome back. In this video we're going to take a look at angle measurement, specifically looking at radians and degrees, minutes, and seconds. Okay, so to start off, we've worked with angles a lot, especially in geometry. An angle, as we know, is just a measurement between two rays. So it's a measurement of kind of like how far we've rotated, or a measurement of rotation between two rays. And usually when we talk about angle measurements, we use, or we have used in the past, degrees, which has this little degree symbol. So for example here, maybe we have an angle measurement of 60 degrees. So in Precalculus, we are sometimes going to use degrees, but we're mostly going to be using another type of angle measurement called a radian. Radians. And you'll know it's a radian if there's no degree symbol. So if you see something like sine of 2 pi, here we don't have a degree symbol inside. So we would assume that this is in radians. This is an angle measurement in radians. Okay, radians are a measurement of rotation, but radians look at specifically, so radians are an angle measurement that examines, one way to think about it is how far around the unit circle that we've traveled. So this isn't the official math definition, but this is, I think, a good way to think about it, is how far around the circle have we traveled. So one quick note, I said unit circle. A unit circle is just a circle with a radius of 1. So a circle where the distance from the center to any point on the circle is just going to be 1. So unit circle is just radius equal 1. And what we're looking at in radians is we're looking at a unit circle, and let's say we have two angles. One here, just at the x-axis, and then our other one is going to be up here also. When we talk about the distance traveled, what we're looking at is the edge of the circle, or points on the circle. And we're trying to find what distance did we travel around the circle to get from one ray to the other ray. And this is closely related to circumference, because in geometry, when we talk about circumference, we're looking at the total distance around a circle. So radians are related to circumference. Okay, so we're looking at measuring angles. So again, we're still measuring an angle, we're still measuring rotation, but we're measuring it by how far we've traveled around the outside of the circle. And so if you think back to geometry, when we talk about circumference, circumference is equal to 2 pi r. And with the unit circle, makes our lives a little bit easier here. R is 1, so our circumference around the unit circle is just going to be 2 pi. So one way to think about 2 pi is if we were to start here at a circle and do one full revolution around a circle and end up in the same spot. So one full revolution around a circle, if we measure the distance that we've traveled around the circle, we've traveled one circumference. In other words, we've traveled 2 pi of a distance, which means the angle measurement of one full revolution is 2 pi radians. If we were to travel halfway around a circle like that, we end up with 1/2 of 2 pi, or pi radians. So we're just measuring the distance we would travel around the circle if our radius is 1. So closely related to the circumference. One quick note is we almost always measure our angles counterclockwise. So we're always going to be starting at almost always the positive x-axis, and then we're measuring counterclockwise from there around the circle. So you'll notice I'm always measuring counterclockwise. Okay, so we can think of radians as a fraction, or a fraction of the circumference, kind of like how far we've traveled around the circle. And we can use this to help us convert between degrees and radians. For example, if we had an angle measurement here, you can see this is a 90-degree angle. We can convert this. Well, first, one way to think about this in radians is we have 1/2 of pi radians, 1/2 of a half of the full revolution, or 1/4 of a full revolution. So in other words, here we just have a measurement of pi over 2 radians. Another way to convert, though, is to use a ratio or proportion, where one way to think about it is we can compare the degree measurement to 1 entire revolution, and that should be equal to, if we take our radian measurement and divide it by 2 pi, or 1 revolution in radians. So if we have our degree measurement and divide it by 360 degrees, that's equal to our radian measurement divided by 2 pi radians. So we're just comparing it to 1 full revolution. How far around the circle have we rotated? So here, for example, our degree measurement would be 90 over 360 degrees equals, we're trying to find the radians, over 2 pi. In this case, 90 over 360 is just 1/4. We can multiply both sides by 2 pi. 2 pi over 4 equals x. So in this case, we can see that x is equal to pi over 2 radians. So using these proportions, we found our angle measurement of pi over 2, which is the same as when we thought about it, dividing pi by 2. So we can use this equation or this proportion to help us out, and then we just plug in whatever we know, and then we're trying to find the unknown. So a quick way we can convert between degrees and radians. Okay, next up I want to talk about arc length. So arc length is related to radians in that we're looking at a circle and we're trying to find how far we've traveled around the circle. So here, for example, we might have an arc length and we're trying to find this distance around the circle. An arc is just a piece of a circle or a part of a circle. So in this problem, notice we have an arc subtended, which just means it's kind of like cut off by 2 rays at an angle of 30 degrees. So 30 degrees right there on a circle with a radius equal to 4. R equals 4. So to start off, one way to work with this is we could look at the circumference or think about the circumference and then multiply it by whatever proportion our angle is out of 1 entire revolution. So we're thinking about how far around the circle have we gone, and we're going to take our entire circumference and then kind of like divide it so that we end up with that smaller portion. In other words, circumference times the degree measurement over 360 degrees, 1 full revolution. So here our circumference is 2 pi times our radius, 4, times 30 degrees over 360 degrees. So we have 8 pi times 30 over 360 simplifies to 1/12, which is 8 pi over 12, which we could simplify to 2 pi over 3. So 2 pi, over 3, and that's our distance. That's our arc length around the circle. So that's our distance that we've traveled for this rotation around a circle with a radius of 4. Arc length is also related to radians, because if we think of a unit circle, so we're thinking of the same angle, 30 degrees, but we're thinking of a unit circle here with a radius of 1. 30 degrees in radians over 360 degrees, we can find it quickly by using our proportion. Multiply both sides by 2 pi, so 2 pi over 12 is x. So x is equal to pi over 6. So pi over 6 radians is the degree measurement for 30 degrees. And we can just take our degree measurement in radians measurement, and then multiply that by the radius if we have a different radius other than 1. So in this case, we can take our degree measurement, pi over 6, multiply that by a radius of 4, we get 4 pi over 6, which is just 2 pi over 3. So notice we end up with the same arc length we got up here, just using the radian measurement, because the radian measurement is just kind of like a measurement of how far around the circle out of 2 pi have we traveled. So you could use this equation to help you out. You could also look at the radian measurement and then just multiply that by the radius. Okay, so that's arc length. Radians might be a little bit confusing at first. You might be unsure why we're using them when we're so familiar with degrees, but radians are going to be really useful and helpful for precalculus, and we'll see later on kind of like how we can more quickly work with angles if we use radians. All right, finally, we're going to take a look at one more way to measure angles. All right, so our last way of thinking about angles is something called degrees, minutes, and seconds. And this is used commonly in, I believe, latitude and longitude, for example. We're not going to talk as much about this, but it is important we know what it is and we are a little bit familiar with it. Degrees, minutes, and seconds are similar to degrees, except instead of a decimal, we're going to split up the rest, whatever's left over, and describe it in terms of these things called minutes and seconds. So instead of just leaving it as a decimal, whatever's left over will change into minutes and seconds. So similar to a clock, it's kind of similar where we need to split it up out of 60. So some conversions, so degrees is going to be the same kind of like definition. There's 360 degrees in 1 revolution. For minutes, 1 minute is written as 1, and then we have one little kind of like dash. And then seconds are written as 1, and then we have 2 dashes up there, so kind of like ending quotation. And for minutes, we know that in 1 degree there are 60 minutes. So similar to kind of like an hour, 60 minutes in 1 degree. And then in 1 minute there are 60 seconds. So in each of these, we're just converting 60 seconds in a minute, 60 minutes in a degree. And we can use these conversions to help us with writing angle measurements in terms of degrees, minutes, and seconds. Okay, so what we're going to do is we're going to have some degree measurement, and then we'll have usually a decimal part of it, and we're going to take this decimal part of it and we'll convert that into minutes and seconds. So let me grab an example really quick. Okay, so here we have an angle measurement, 21.256 degrees, and we want to convert this to degrees, minutes, and seconds. So to start off, the degrees is going to stay the same. So 21 degrees is done. Then we take the remainder, 0.256, and the remainder is in terms of degrees. So one way to think about it is we have 0.256 times 1 degree. To change it to seconds, minutes, there are 60 minutes in a degree. So we could take 256, and instead of multiplying it by 1 degree, we can multiply it by 60 minutes. So we just take 60 times 0.256, and then we end up with 15.36 minutes. So 15.36 minutes. So we have a number of minutes. Again, we're going to take the integer number. We're just going to take away the remainder and take 15 and put it up in our answer. 15 minutes, so 21 degrees, 15 minutes, and then one more time we're going to take our 36 and convert that to seconds. So we're taking the remainder and converting it to seconds. So 0.36 minutes, or another way to think about it is 0.36 times 1 minute, and that's equal to 0.36 times, instead of 1 minute, we're going to write 60 seconds. So again, we're taking 60 and multiplying it by 0.36. We get 21.6 seconds. And then we're done. We can't break it up anymore. So we're just going to write 21 degrees, 15 minutes, and 21.6 seconds. And this is our answer for converting 21.256 degrees into degrees, minutes, and seconds. So it's written as 21 degrees, 15 minutes, and 21.6 seconds. So just taking the remainder and then multiplying it by 60 to convert to minutes and seconds. We might also be asked to convert from degrees, minutes, and seconds to actual degrees. For example, we might be given 50 degrees, 6 minutes, and 21 seconds. So in this case, what we can do is convert the minutes and the seconds in terms of degrees. So we can split this up. So we're going to have 50 degrees, we know that. Plus, we have 6 minutes. 6 minutes. So one way to think of this is 6 times 1 minute. And we know that 1 degree is equal to 60 minutes. In other words, 1 minute is equal to 1/60th of a degree. So instead of this minute here, what we're going to do is write 6 times 1/60th of a degree. So we're changing our minutes into degrees, and we're doing that by dividing by 60. Similarly, for the seconds, we can think of the seconds. We have 21 times 1 second. We know that 1 minute equals 60 seconds. So 1 second is 1/60th of a minute. So 21 times, instead of 1 second, we're going to do 1/60th of a minute. And then we can go even further and then change minutes, like we did before, into degrees. So using our conversion up here, 21 times 1/60th, we can think of this as times 1 minute, because that's our units. So 21 times 1/60th times 1 minute is 1/60th of a degree. So overall, we have 50 degrees plus 6 times 1/60th of a degree plus 21 times 1/60th times 1/60th. In other words, for seconds, we're dividing by 60 twice in order to convert our seconds into degrees. So overall, 50 degrees plus 6 divided by 1/60th is just going to be 1/10, 0.1, plus, and here we have 21 divided by 60 divided by 60, or divided by 3600, 0.00583, repeating. So about 50.1, and then we're adding these up, 1058 degrees, right around that. 0.1058333, repeating degrees. Okay, so that's how we can convert between degrees, minutes, and seconds. And decimal degrees is what we call the normal degrees we've been working with, and then vice versa. So in this video, we learned about what radians were, how to convert between radians and degrees, and we also learned about one more way of measuring angles, which is degrees, minutes, and seconds, and how to convert between decimal degrees and degrees, minutes, and seconds.